Antibodies linked to interferons is a potential solution to COVID-19. But how and what are they? The infection process of COVID-19 involves two phases. The first phase is when the novel SARS-CoV-2 virus interacts with the innate immune system while it's replicating, and the second phase is when the specific immune system activates after a delay. When the coronavirus enters the body, the internal innate system immediately gets activated. The phagocytes in the innate system, such as macrophages, are then supposed to eliminate the virus. However, the coronavirus suppresses the innate response. So, the innate is a bit futile. This leads us to the first phase of infection. Now, let me quickly remind you that our body's innate system is suppressed and our body's second line of defense, the specific system, hasn't yet created antibodies as it's never been exposed to the novel virus. During this phase, the virus replicates fast and we start to show common viral symptoms. This phase goes on until B cells produce antibodies. Antibodies are proteins that surface on B cells' membranes. Only specific antibodies can fight off specific antigens. Antigens are toxic proteins that surface on invading pathogens. This is where it becomes a problem. In this second phase, the body makes antibodies to make up for the antigens. The body creates so many antibodies that this usually results in inflammation in the body. This severe hyperimmune reaction can cause a cytokine storm. Not that type of storm, this type of storm. So what do we do in response to this? We improve both the innate and the specific systems. During phase 1, our body cells get infected by SARS-CoV-2. The infected cells then produce interferons. Interferons are proteins that regulate immune response towards invading viruses. They essentially get rid of infected cells and assist phagocytes, and there are many different types. Right now, interferons beta-1a and alpha-2b are being researched as potential solutions to SARS-CoV-2. They are also genetically engineered and injected. But interferons alone have many problems and side effects because when injected, they travel to all cells, whether they are infected or not. This is where monoclonal antibodies come into action. These are clones of specific antibodies that are created in labs. Linking the right antibodies to the right interferons is called antibody-interferon fusion treatment. Because the antibodies are linked to the interferons, the antibodies will be able to guide the interferons to only the infected cells so that the interferons don't cause any systemic damage. To stop the viral replication in the early stages, we must inject the fusion. This way, later, there won't be an excessive number of antigens. Maybe all we need is the right balance of immune reaction at the right time.